Hi everyone, it's Jenny from Norman S. Wright. A few weeks ago I covered heat pumps and how they work, but there are different types of heat pumps like air source heat pumps, water source, and ground source. So let's talk about the different types of heat pumps today. So let's get started. There are three main types of heat pumps: air source, water source, and ground source. They collect heat from the air, water, or ground, respectively. Let me bring up the system from the heat pump video. What I explained in the heat pump video was an air source heat pump. In heating mode, it extracts heat from the outside air to heat the air that is inside the space, and in cooling mode, it extracts heat from the space and rejects it outdoors. Air source heat pumps are also known as air-to-air heat pumps because you're taking heat from the air and transferring it to supply air. Your home air conditioning system is very likely a ducted air-to-air heat pump. So, as I mentioned in one of the previous videos, the indoor heat exchanger would be ducted to the ducts in your house that supply air to all the spaces. A ductless system could be like a VRF, which I explained a couple weeks ago as well, or a mini-split system. Mini-split heat pumps are primarily seen in smaller residential systems, and unlike VRF, which can provide cooling and heating to the system at the same time, mini-split systems can only provide cooling or heating at any given time. Now let's move this over and let's look at a water source heat pump. Let's bring back the heat pump drawing again. A water source heat pump uses water instead of air to extract and reject heat. So instead of running the refrigerant through a coil and using a fan to blow air over it to extract or reject heat, there's a water loop that works as a refrigerant to water heat exchanger. So to look at how this works, let's erase this outdoor heat exchanger. So let's look at the water loop. This is usually done by having a coaxial heat exchanger that has the refrigerant run on the inside of the tube and a water loop run on the outer tube. So let's connect the refrigerant to our water loop. And then let's connect a water in and a water out to our water loop. During cooling, the lower water temperature draws the heat away from the compressed hot gas of the refrigerant. In heating, which is the mode that is shown in this drawing, the refrigerant draws the heat from the building water loop and exits as warm temperature, low pressure gas. So where does this water come from? Water source heat pumps would be connected to a boiler to add heat and a cooling tower to reject heat. I'll cover the details of these in future videos, but right now let's just draw a line here and know that they're connected to them. Let's move this over and talk about ground source heat pumps now. Ground source heat pumps, also known as geothermal heat pumps, use the fact that the ground beneath the surface of the earth remains at a relatively constant temperature throughout the year. It's warmer than the air above it during the winter and cooler than the air above it during the summer. So let's bring back our heat pump drawing again. And then again, let's erase the outdoor heat exchanger. So we're looking, that's in heating mode still. So instead of having the water loop like in the water source heat pump, the loop is buried in the ground near the building the system's in. You'll have a plate heat exchanger here. One side is connected to the refrigeration loop and one side is connected to the water loop that is buried in the ground. So this is ground level. Below ground level, you would have a water loop or a water plus antifreeze loop that would flow through this side of the plate exchanger. And then the other side is the refrigerant, so your heat exchange is happening between these two sides of the plate exchanger. The loop can be buried either vertically or horizontally. It circulates the fluid that absorbs the heat from or relinquishes heat to the surrounding ground, depending on whether the ambient air is colder or warmer than the ground. And then that is transferred to the refrigerant. So let's pull all of these back up so you can look at all of them. And that is an overview of air source, water source, and ground source heat pumps. Don't forget to subscribe to our YouTube channel, and thanks for watching.